Okay, folks, in the latest installation of my GPIO, the Raspberry Pi version B, revision 2, GPIO controlled LED display, and this is my latest, and this is what's going on. So you see that's the circuit board, and the GPIO, the Raspberry Pi is here behind it, on top of a speaker, and I got it showing various information such as the time, which is 3 a.m. in the morning. It's 12:30 in the morning, and it's June 29th, and it's the temperature in Fahrenheit, temperature in Celsius. CPU 16%, load is 0.25, uptime is 0 days, and the cycle repeats. And so this is a Raspberry Pi directly driven by the GPIO, as you can see, it's a connection here. Okay, directly driven by the GPIOs, and current limiter, a 100 ohm resistor, and I got 6 transistors here. So I got 8 wires connected to the 7 segments plus decimal point directly to the LEDs, 7 segment LEDs, and the 6 transistors. Each one controls each digit going to the ground. So power goes positive, the output goes to one of the segments, each of the segments, and then these are common cathode, so the cathode goes to the transistors collector, the emitter goes to the ground, base goes to the resistor, which is I think it's pretty high, I think it's 470 kilo ohms, to one of the 6 GPIOs. So one of the switching GPIOs that goes to the transistor just switches on each digit one at a time. And at any moment, only one LED is lit. So 7 LEDs, and there's like 40 something, 42, 48, 48 LEDs lit one at a time. I slowed it down for you so you can see that it's flashing. Okay, only one segment at a time. So like the L, only 1, 2, 3, 4. So one goes on and then off. The next one goes on and off, on and off, and goes through the six digits. The LEDs I got on Amazon, and it's 2 digits, so it's actually 3 modules. Common cathode, and they're called dynamic, so that the 2 LEDs, the 7 segments plus the decimal point, are wired together, and it has 2 cathodes, one cathode for the first digit, another one for the second digit. So you can connect the 7 segment plus decimal once, and then and you control it by switching the cathode, and I have 6 of them together, 3 of them, 2 each, 2 times 3, 6 segments. You can see the decimal sometimes is lit. And just to note, the total current usage measured from the ground through the resistor here, the 100 ohm resistor. The total current is 10 milliamps, and you're not supposed to draw more than 16 milliamps out of each GPIO for a total of 50 milliamps. So if you're gonna use all of them, you have to make sure that they don't add up to more than 50 milliamps. And these, when measured with a multimeter, don't add up to more than 10 milliamps, usually less. And again, it's switching one segment at a time, so at any given moment, one segment is using about 10 milliamps. And the controller, to control it, you can use any language. I chose Perl because I just happen to know Perl. Usually Raspberry Pi, the preferred language is Python, and the Python language looks pretty easy to use also, so it's something good to learn, Python. Also, there are it's 17 GPIOs, and there are extra ones on the board, but you have to do some soldering to use it. I believe right there, P1 are the extra GPIOs, and these are also good for other things. I forget what they're used for, but I think you can add extra GPIOs from those also. But for sure, these guys give you extra GPIOs. Right. And the cable, I got them on eBay. I ordered the cable on eBay. Okay. And it should show you where. It should show you where I got them at eBay. And summary, and I actually got it from this guy, which is GPIO board. Got it from this guy here, which they shipped it pretty quick. Glitch Science. 100% feedback. They shipped it pretty quick. Let me show you the transfer. They paid $10 for it. The GPIO cable, I got it from this guy, and that's the tracking number, which sent on the June 8th, and I got it on 10th, so that's 2 days, and 8th and the 7th. I ordered on the 7th, and he sent it on the he dropped it in the mail. The mailman got it on the 8th, so that's 1 day, so that's pretty good. Another one I just ordered is from these guys. Pretty responsive. This guy sent them a bunch of emails, and they sent it back. This was actually an order that I requested because they had a cable that was 6 inches, and I asked for a 12-inch cable, and right away they posted a new auction, which I purchased from these guys. Here it goes. Electro resales, and they also got 100% feedback. I hope they'll send it quick. Let me just take a look at the tracking number. Well, it's I guess mailman got it already because it's showing where it's at. $15 plus shipping, $1.69 for shipping. The LEDs I got on Amazon. Let me see. I put in a password. Which I got it on Amazon. The LEDs. You can use common cathode because it's easier for logic. It's just easier because the common anode, when you switch the GPIO off, and it gives a negative voltage up to switch line, you gotta switch off the GPIO, so it's like reverse logic, so it makes it harder. So make sure you get a 7-segment common cathode. Okay, that way you could directly drive it, and make sure you use limiting resistors. At least 100 ohms, 150 ohms would be better. And these are very bright. As you can see, it's very bright. You can see it's very bright. Okay. And I got these on Amazon. You could probably get them. Actually, it's about the same price on eBay. And it came in 2 packs. And what I meant by dynamically control, what I was trying to explain before, it's dynamic so that the segments are wired together. So the 7 segments plus decimal point are wired together in parallel, both of them in parallel, and the cathodes are separate. So if you put power to this cathode, it will light up digit 1. Power to the second cathode, it will light up segment 2. And you gotta alternate them, so you gotta make sure you have some way to multiplex the 2 of them, because otherwise you'll get the same number. So if you got 1 here, if you light them both up at the same time, they'll both be 1. So if you make it 2, they'll both be 2. 3 will both be 3. So you gotta have a way to alternate them with a multiplexer, so that it's, when you switch to the segment 1, it's 1. Segment 2, it would be 9, let's say. And that's important because they have ones that are 4 segments and 6 segments, but that's rare. I've seen usually it's 4. And and there's some there's 3, but some of them are 4. Like so yeah, some of them are 4. So when you got 4, then you gotta. And there are 2 different types. There's static and dynamic. So here's a static common anode one. And static means the pins are completely separate from each other. Digit 1 and digit 2 are completely separate. Okay, and there's reasons for those too, but for what I'm doing, we have a limited amount of GPIOs, so I'm going to use a dynamic. That's good. So once again, I can show 9 digits plus different letters. see different letters, and I can show various information on the system. And again, I try to keep things simple, just to demonstrate the GPIO, and not to demonstrate how fancy electronics. So I want to demonstrate simply how to use the GPIO using fewest number of parts. So just massive wiring and the fewest resistors and fewest transistors possible. So that would be like the fewest parts you can possibly use to drive this system here, this LED system. 6 segments. And that's probably one thing I could probably make it faster. And if I make it so that there's no delay, I set it to 1 milliamp delay before, but this time I have it set to no delay. And no delay, you can see it's solid, but it's not actually solid. It's just switching as fast as it can, so it could be like a few kilohertz switching. So right now it's still switching, but at higher speed, just without a delay. So it's switching at, I don't know how fast. The switching could be in the megahertz, so from on to off, but from one segment to the other, it's probably in the kilohertz range. Okay, there's all my other parts. Got a modem here that I took apart because it keeps it cool. Other routers and stuff, massive cables and junk. That's my server.